All right. Today I'm going to give a review on Math 166 final exam, and I also have some lecture notes I recorded in the last semester. I'm not going to repeat those problems. Maybe I should also post it on my website here for students can review for the final exam. So how do you prepare for the final exam? There's not enough time, for you to prepare. My suggestion for you is you can summarize, trying to on a piece of paper summarize some ideas you already learned about how to check this test series. Series is a convergent, divergent. At least you should memorize a complete statement of alternating series test. Why this is important? I noticed that 4 students use the alternating series test to prove some series divergent. But the statement, if you remember the correct statement, nothing to do with the divergence. Just say under those 3 conditions, right? Bn, decreasing positive and the convergent 0, then the series is convergent. But never say when the series is divergent. So you cannot use alternating series test to prove it is divergent. Okay. So my suggestion to you is, I post as a review lecture notes. I did it before on the website, and you can look at that. What you should do is don't look at my solution, okay? And try to do it by yourself, okay? Yes, you have to spend 5 minutes, still cannot get it, and read it, okay? But don't always do like that. Then when you get, like, especially to prove something's convergent, maybe you use a different ideas. That's okay. That's multiple ways. But you find the proof, then you look at my one, you conclude that's convergent, but my one is divergent, right? And why? Where's the mistakes you have to look at? Okay, so you can view my lecture notes as like a solution. So don't look at first. Try and do it by yourself. Okay, I'm going to post more on the website. Those are from my previous lectures in the last semester and then in 2018. Okay. Okay. So today I'm going to talk about the final problems on final exam. Previous final exam, that's version 1. Okay. The first problem is if you have a function, okay, find the derivative of this function. Now, when you look at the function, first thing you have to do is to check whether you can modify this first. Sometimes the original version is very complicated, and it's much more it's difficult to find a derivative. Okay, this is definitely you have to apply the chain rule to find the derivative. But we don't like the radicals. When you find the derivative of the square root of 1 plus x to the 4th, it's complicated. But this is a natural log. So the natural log, you can always remove the square root. So then it will be much easier. Okay, when you differentiate, 1/2 is always here. Then this goes to the denominator. Then you differentiate 1 plus 4 x to the 4th power is 4x cubed. So immediately you get this. Then you simplify a little bit. So those are problems so easy to get points. Only within a couple seconds you already get answers, right? Right? That's my opinion. So don't lose 12 points for this problem. Okay. Now the second problem is we know the half-life is given. Okay. T equals 100 years. Okay. A sample of a substance has a mass of 8. The initial, the initial mass is 80 mg. Okay, find the formula for the mass of the sample, and that remains after t years, and when will the mass be reduced to 10 mg? Okay, so there are 2 questions here. and you have to find the general formula. Okay, we want to find out quantity. I'm going to use a Q. Okay, a quantity. You can P or Q, doesn't matter. Yeah, find the Q. Okay, Q is from the initial quantity e to the k and the t. All right. So what they have to do, the initial quantity is given. Okay, so it's given. Yeah, the initial quantity is given, but we don't know the k. We have to find the k essentially. Okay, you have to understand the half-life. Half-life means when t equals capital T, this is going to be half of the original quantity. Okay, you don't need to know the original quantity here. So here it's going to be Q. Say I never remember this formula, but you can derive it. Okay, then initial quantity is gone. Then K capital T is going to be you put the natural log on both sides, and that is answer. Okay, so you find the K. T is 100, so it's 100, 1 over 100, 1/2. Okay, so K is negative now. Okay, remember K is negative because natural log of 1/2 is negative. All right, so you get a general formula. Once you get a K, then QT you have to write on the formula. And this original initial quantity is 80, and E to the, that's your K and the T. That's a formula. Okay. The next question is find the T at which or when, right? When the quantity is going to be 10 mg. Okay. So all I have to do is just solve the equation. Just set this to be to 10, right? 10 mg is 10 equals 80 E. Okay. Right? And then you simplify, and then you divide both sides by 80. So 1 over 8 is going to be this. Right? And in order to get T, you put the natural log on both sides. So natural log 1 over 8. This side is gets 100 and T. And then you solve for T. It's a linear equation. So the linear equation, it's going to be natural log of 1 over 8 and the 1 over 100, natural log of 1 over 2. And then simplify a little bit. How do you simplify? Well, it's going to be 100. That's cool, right? Then this is your mathematical skill here. Don't make mistakes when you simplify. So here's will be natural log of 8, natural log of 2. Why? Because you can put a negative sign in front of natural log, and then both are canceled out. But natural log of 8 is going to be 2q. So immediately you get 3 natural log of 2, natural log of 2. So natural log of 2 is canceled out. And then answer is 300. So 300 is the amount, the quantity, the mass is reduced to 10 mg from 80 to 10. All right. A similar problem will be on the final exam. Listen, but the question will be different. We will ask you to find the time so the mass is reduced to 10% of the original instead of, you're not given the initial quantity even, for example. But this is the idea, you need to clearly write down all the steps. So maybe you have to find, maybe the half-life is given. Maybe you have to find a half-life, right? Yeah, if you're not given, then you have to find it. Use the data. If you're given, then you just you have to use the formula. If you're given the half-life, then just do like what I did here. Okay. So maybe you're not given the initial quantity, but it's okay. The initial quantity does not play any role here. If you know what percentage of the initial quantity will remain after t years, then you find the time t, right? Then the initial quantity will be canceled out. Okay, you don't need to put that. So this is if you understand that, I think that this is not a difficult problem. There is no trick here, just direct computation. Okay, so that's called, yeah, with 12 points. Yeah, find the limit of this function. Okay. Clearly, when you plug 0 for x, you get 0 over 0. So this is 0 over 0 type. That's why I use a L'Hopital's rule. You can, yeah, make sure, you know, when you can use a L'Hopital, it's 0 over 0 type. Therefore, you can apply L'Hopital's rule. So it's 2x. When you differentiate, it's 1 plus x minus 1. And you have to simplify a little bit before you continue. Okay. So you get 2x. You move this to the denominator. I think it's 1 minus, it's actually negative x here. Okay. Yeah, combine the numerator, you will get 1 plus x, 1 minus 1 plus x, right? So you get negative x over there. But this x canceled out. So you get negative 2, 1 plus x. And then you shouldn't use a L'Hopital's rule here. You stop here because it's not a 0 over 0 type. So that's going to be negative 1/2. I think that these 3 problems, there's no tricks you can use. Basically, it's pretty straightforward. Okay, but for the integrals, you do need to think about how to evaluate integral, like 4 over x squared minus 4 dx. Okay. You memorize the formula. If you don't memorize the formula, you have to decompose it into 2 simple functions. So 4 over x squared minus 4 is 4 over x minus 2 and x plus 2, right? Yeah. Now you can try to find the coefficients, but there's a quick way to do that because you can try like this, minus x plus 2, to see if you're able to get the same constant. Can, you know, combine them, you get x minus 2x plus times x plus 2 in the denominator. The numerator, why have you choose a negative sign? Because if I choose a negative sign, I get a constant on the top when it combines those 2 terms. X will be gone, x plus 2 minus x minus 2, I get 4. So already give you the 4, there's no need you can do it. So that's a very quick way to get the decomposition. Because we want to save you time. That's why we don't want to spend lots of time to find A and B. That's a quick, direct way to do that. Then, you know, maybe if I don't put the 4 on the top, but you have to divide by 4 because you create a 4 here to combine those 2 terms. All right, then the integral of 4 over x squared minus 4 dx is going to be integral of the first term. Okay, and then this is going to be natural log absolute value. Don't forget absolute value. And plus constant. Then there's no need to combine them into one fraction. All right. That's it. Well, 4. 4 is already, if you put them together, combine, you get 4. Yeah. Okay, you see, x plus 2 minus x minus 2 is going to be 4. Okay, right? Yeah, if you combine those 2 terms, you get x. All right, so now integral of a twice a cosine square x minus 1 dx. Yeah, that's the question. How do you integrate cosine square x, right? You have to know the formulas. Cosine 2x equals 2 cosine square x minus 1. Okay, and equals 1 minus 2 sine square x minus 1 equals cosine square x minus sine square x. This is a formula. Then you immediately can say, oh, that's trivial, right? That's going to be just cosine 2x dx. You see, right? And then it's going to be sine 2x. I have to divide 2, then usually just, just, yeah, if you know this relationship, just 5 seconds you get answers. There's no need to spend lots of time. Okay, how about this? This one takes a little bit more time. The question is, yeah, this is a difficult problem, honestly. If you haven't done enough problems on this side. So there's natural log of that. That's x cubed, right? X squared. So you don't like natural log of x, you have to get rid of that. You have to differentiate. So you have to differentiate in order to get rid of a natural log. So use a integration by part. So remember, there's only one and only one problem. You can use the integration by part. Don't use that for all the problems. This is u and the v, dv, right? So what is v? V should be equal to x cubed, right? It's obvious. When you differentiate, you get v. So that's going to be uv minus v du, right? Then u is a natural log of x, v is x cubed, and v is x cubed. Du is going to be 1 over x dx. Okay, then you find the entire derivative of x squared. And that. Okay. But if I ask you to do this, okay, think about that. I'm not going to show you how to do it. Okay. So this is a good exercise, and you use a totally different idea because you cannot use the same idea to get rid of e to the x, because when you differentiate e to the x, you're still there. It's e to the x. No matter how many times you differentiate, it's always e to the x. So you cannot kill it. You have to do the opposite to it. You have to kill x squared. X squared becomes x and it becomes constant. Then you can evaluate it. Okay. All right. So the next problem. Find the length. Okay, of the curve. The curve is given by. Now, when I was grading the test, there are several students did not write on the formula for the integral. Didn't we have the integral? Yeah. What is the first problem? This is the parametric equations. Right, but here it's given by a regular equation. Okay. So very first step, you have to write on the formula. This is integral from in general it's AB, right? Write on this. Then you have two options, dy over dx square plus 1 then dx. Or you have another one we call CD, right? 1 plus dx over dy and dy. And clearly I have to use the second one because we are given x equals square y minus y. So L for this, you are right on the formula first before you do the problem. Okay? Then it's going to be 1 to the 4, and it's 1 plus the derivative of x with respect to y is going to be this and dy. And then next step is how to simplify, how to evaluate the integral. And I'm pretty sure you can get rid of radicals. We carefully choose a function. So you have to combine them into a square. Okay, then you get rid of radicals. So let's do this. It's going to be quarter y and minus square y and plus 1. Right? let's see, twice of, I'm not sure we can do that, okay? Oh, set up an integral. The problem, just set up an integral, not find the length. Set up an integral, that's why I'm stuck here. So you're not able to evaluate. Yeah, but it's maybe we can, but it's just a waste of time. We don't need that to, yeah. Just set up an integral, okay? Set up an integral, that's all I need. I don't need even waste time to just set up an integral, okay? You can use MATLAB or some other software you're familiar with, just tap the function and get the answers, okay? So I don't need to do this, okay? So we are given the function f of x, 1 plus 5x plus x to the fifth, and find this and the derivative of this function, okay? The function we choose, you are not able to find the inverse function. So you cannot find the elementary formula for the inverse. First thing you have to do is you look at, okay, trying to guess and try. When f equals 0, it's going to be 1. So that implies the inverse is going to be, the value of the inverse at 1 is 0, right? It's the same. Okay. Second, what you have to do is to write down the formula of this. Don't forget to write, even you know how to do it, you know this is the formula in your mind, but you have to write down the formula first. Whatever formula you're using, write down it first. Okay? Then, okay, then you see, oh, I already know this one, so you put it, right? Then it's clear, I just need to find the derivative and evaluate the 0, right? Then you start, then you know, this is the motivation, why you have to find the derivative, right? The motivation is because there is a derivative of the function here. You have to find out, right? Then implies f prime 0 is going to be 5. Then you go back. This is a perfect, right? Everybody knows what you're doing here. Okay, it's very important how to express your ideas clearly, step by step. It's very important. Okay, sometimes it's harder to read the solution on the test because it's everywhere there was something that, so I cannot figure it out. Okay, and you have to learn how to step by step. You see, what is the purpose? Why I have to find derivative? Because it shows up in this formula. So you begin with a formula, then you get motivation to find the derivative. Then you add it and go back and get answer. But this training is important. So I keep telling the kids, say, why you want to study with math with me? I say for 3 purposes. 1, improve your, mathematical expression skill, because you have to express clearly. Usually they don't care when they from middle elementary school. They just I want to find answer. Answer is here. It's great. Just answer. I ask to have some show me the details step by step. So then, of course, you have to also learn what you're supposed to learn. Yeah. Okay, and also have to solve certain type of difficult problems. All right, so the next problem, find an equation of a tangent line to the curve at the point corresponding to the value of the parameter. So this curve is given by this, okay? Okay, find the tangent line at the point when t equals what, right? So to find the point, first of all, I have to find the point, right? The point, first of all, let's say, what is the point? The point. The point is when t equals 1, x, right, is going to be 1 plus 2 times 1, it's going to be 3. And that point, the y coordinate is 1 cube minus 2 times 1, it's -1. So you get the point. Coordinate, 3 and a -1. Okay. Then you have to find the slope. The slope. Okay. So if we can express like that, it's great because we can easily read it, right? You want to find the point and you find the slope. When you're done, then you get the equation, right? So don't just try to find the derivative, blah, blah, blah. Then you messed up, you didn't find it right, and what you got, we don't know your motivation to find the derivative. Okay. Okay. It's on the scratch paper, yes, you can do that, but when you present your work on the piece of paper, you have to organize it. Just like when you in the lab, you do do some experiment, right? You have to write down, you have to report. Okay, step by step. So slope, and you write down the formula. The general formula will be dy over dx, right? If you are able to express y in terms of x, that is a slope. And the slope when x equals that point. But we're not able to do that. So what we do is, we have to find y prime when x prime when, find the derivative. That's the formula. You use a chain rule, and this is dy over dt and dx over dt when t equals 1. So you have to find the, then you find the derivative. You can continue, find the y derivative, 3t squared minus 2, and here's and 2 when t equals 1, right? You can also express like this, dy dt dx over dt when t equals 1. Yeah. So, right, and you find the derivative y as 3t squared minus 2 and plus, then you plug 1 for t, you get 3 minus 2, and the 2, it's 1/2. So you have a slope, you have a point, then you get the equation y minus -1 equals 1/2 x minus 3. That. Okay. Okay. Now the polar equation. Yeah, sketch sketch the curve and find the area. Okay. How to sketch the curve? It's 2 minus cosine theta. Okay. So you just choose a few values. Here's a theta. Here's r. So when theta equals 0, I just choose a few of them. When theta equals 0, it's 2 minus 1, it's 1. When theta is pi over 2, and it's 2. And the pi negative, it's going to be 3. So 3 pi over 2, you get 2. And the 2 pi, you go back to 1. So you know the general shape of this graph. Right? R is never be negative. So it's not like going to be like a hot type. There's 3 types only. One looks like that, right? Other one looks like that, right? Then the one looks like that, right? There's 3 types. Or maybe you rotate a little bit, but clearly, if I is positive everywhere, this must be this form. Okay, so you can choose here 1 when theta equals 0, and then you have a 2, and the 1, 2, 3, and the 2, right? So it's 1, 1, it's 2, -2, -3. So clearly, very quickly can draw the graph. First, we should know how does the graph look like. Okay, and then just plot 4 points and connect them. Then the next step is to find the area. So you write down the area formula. Now, when you finish your first part, go back to read the question again. That's a good habit, because what? You ask yourself, have I answered the question already? Oh, there is a second part, find the area. Don't miss that. That's something we'll miss it. Then draw the picture, then move on. Okay, completely forget what the origin want to do. Okay. So you write on the formula, and that's from 0 to 2 pi and r squared d theta. Okay. Then you put into the formula. and 2 minus cosine theta. And this is similar problem is on the test, right? Yeah. So you squared, you get 4 minus 4 cosine theta plus cosine square theta d theta. But cosine square theta should be converted to cosine 2 theta plus 1 divided by 2. Okay, so the integral, I think what you get here is like that. 4 plus 1/2 is 9/2, and minus cosine theta plus cosine 2 theta over 2 d theta. So the integral of cosine theta and cosine 2 theta will be 0. So all I have to do is this. Simplify it, and again the 9 pi over 2. Okay. Yeah. So integral of cosine k theta d theta when theta from 0 to 2 pi is always 0 if k is integer. Okay. So you don't need to waste time to find antiderivatives. All right. Okay. So here's and determine whether this is a convergent or divergent. To me, we already know that, right? This is divergent. Okay. Why it's divergent? Because eventually you get the square root of this is very similar to the integral of u to the 1/2 du. Okay. After you use the substitution, that you end up with this. So it's divergent because p is less than 1. If p is less greater than 1, then it's convergent. Okay. So yeah, pay attention to this type of integral. I repeat again, it's not 1/2, just in general. Okay, in my last review class, okay, determine when it's convergent, when it's divergent. Okay, and it starts from 2 to infinity. Okay, give it this part. Okay. Yes. And this is really similar to this. Okay, those two. So you think about. Okay, so here you use a substitution. Oops. You use a substitution. You will get I don't know what happens. Okay, use a substitution. Yeah, something wrong now with the file. I'm not gonna fix. There's some warning sign on the top. All right, so use a substitution. You left u to be natural log of x. Okay, then this integral becomes natural log of 2 to infinity, and this is a square u du. Okay. And this is clearly divergent. I'm not going to waste the time. You know that this is you find the entire derivative of this function because p is less than 1. Okay. P is less than 1. Okay. Now we have a sequence of, we have several problems on series. And this is a problem. I think it's very similar to the one on test. Right? When I look at this, it's obvious it's divergent. Question how do you prove it? Well, it's not exactly. But the best way to solve this problem is not nth term test for divergence. This must be P series test. Okay, this is the best way to do. This is an n, so you figure it out, right? You drop n, drop one, then you get 1 over n. That's your Bn. Okay, and then you look at the limit, which is always equal 1, and you look at the Bn. This is divergent. Okay, why? By the P series test, you have to say that. And P is 1. Then you implies the original series is going to be is divergent too by the limited comparison test. Okay. Can you use a comparison test? No. You cannot easily compare with Bn. Because n is less than equal to Bn. But the Bn is infinite. Does the so this side is infinity does not imply this is going to be infinity. Okay, that's the problem. Because something is less than equal to infinity, but does not mean that term, that number is infinity. So you cannot use the comparison test. Okay, cannot use the comparison test. You cannot use the nth term test for divergence because the nth term indeed a converging to 0. Okay, so we cannot use a comparison test. Okay, and the limit of n is going to be 0. Okay, so we cannot use a nth term test for divergence. Why nth term test for divergence? If the limit is not going to be 0, then it's divergent, right? If it's 0, then you cannot say. That's the first point. Second point. All right, and third point, if you look at, if you want to try to use a load test, the answer is going to be 1. Now, of course, if you make mistakes, you're not going to win. Then you always conclude that it's convergent. Okay, so you cannot use the ratio or load test here. Okay, so only the limit components works. All right, so the next problem. When I look at this, I think, oh, that's obvious convergent. Why? Why? Obvious convergent. Oh, obvious convergent. Okay, it's convergent. It's obvious convergent, and you can use. Okay, if you look at the limit is 0, so you cannot use a. You cannot prove a divergent. The reason is that 4 to the n is much larger than 3 to the n. That's the reason. Okay, so n is less than equal to 4 to the n, 3 to the n. So it's going to be 3 to the 4 to the power n. That's my Bn. Then use a comparison test. So this is a convergent. Why? You can say geometric series. And I is 3 over 4 less than 1. And everybody knows that what we're talking about, right? Yeah, you have to say geometric series. Okay, this implies n is convergent by the comparison test. Okay, you can use a limit comparison test. You can use, but you cannot use a load test, ratio test. It's difficult to find a limit. Okay, it's more difficult to find a limit. Okay, of course you will say, oh, 3 to the power n. Let me try to use a ratio test, right? It's very natural idea. Okay, when you use a ratio test, your mathematical ability is not good enough to handle this, I should say. I'm not discouraging you, but in general. Okay, and you're more likely you're going to make mistakes if you're trying to simplify. Then you're going to lose points if you make mistakes. No, it works, but I can do that. Maybe you can. Just kidding. But that's a much hard. You know, you have to find a limit. The question: how to find a limit, right? How do you find a limit? Okay, how to find a limit? But when you're trying to simplify, if you create your own algebraic rules to simplify, then you make mistakes. Even you use the right, yes, the ratio test, a root test works. Yes, your conclusion is still convergent. Why I still lose the points? Because your argument, there are some gaps there. So you're not getting full credits. Okay? So I'm gonna do this, right? I can say watch out, right? I take 3n out, I take 4n out. What is left? The left here is going to be 1/2 watch out, right? Can you see that? I take 4n out. Okay? Then this is going to be disappear, right? So this is going to be 3/4. And here, okay? Now you have to tell me this numerator, this denominator convergent to 1, okay? This is convergent to 3/4, it's less than 1. And why this is convergent, have given us a proof, right? Because we never told you this. You can just assume this 1, okay? It is not always equal 1, you know, this, yes, the question is, why this is going to be 1, right? That's another question, mathematical problem. It's not always. You know, recall that because it's there because the power is 1/n. No. For example, if I just put the 1/n here, it's not a good example. But anyway, this is going to be 1. Who can give me quick proof? Okay, here's a simple proof, okay? But you have to give argument, otherwise you lose 2 points if you just say it's going to be 1, okay? So it's 1 plus 1/2 to the n, okay, clear. It's going to be less than or equal to 2 greater than or equal 1. Do you agree? Yes, you agree. Okay, therefore, sorry. Okay, now what is the limit of 2 to the 1/n? It's convergent to 1. Do you agree? This is convergent to 1, right? Then the squeeze theorem shows that the middle one convergent to 1. Right? So that forces the one in the middle because both sides convergent to 1. The one in the middle convergent. But you have to prove that. This will be separate the problem actually to prove that this limit is going to be 1, right? So I just said that it's much more difficult. All right, so next problem. Now, whenever you see an alternative series test, don't always use the alternative series test. Remember that, okay? Write down this sentence. Okay? Do not always use alternative series, okay? Because sometimes it's impossible. We make it impossible. Like, yeah. So Bn equals sine n over n squared. This one, first of all, So if you use alternate series, you have to mention that conditions listed in alternate series. So this one, Bn, change signs. So the first rule is already valid, cannot be positive. Second, we don't know whether it's decreased or not. I know. The third one, yes, the limit is going to be 0. It's clear. Because the numerator is always bounded between negative and positive. The denominator is larger line. So the 3 conditions listed for the alternating series test, only the last one is satisfied. So we cannot, cannot use the alternating series test to prove the convergence. Okay, but it's convergent. It is convergent. So do not always assume, that's a sentence you have to memorize. Do not always use alternating series test for alternating series. Clear? Okay, at least do not use that twice if you see 2 alternating series on the test. Okay, we are not going to allow you to use the same alternate series test for both problems. We design the problem like that, like this one. Okay. Yeah. We wanted to familiar with all the, like this, you know, you are the guy to fix, use a toolbox to fix all the stuff, right? Furnaces, water heaters. So when you take a test to get a license, they wanted to get familiar with all the tools. There are some problems that design, you have to use this particular tool to do that. There's no uniform tool. You can fix all the problems, okay? Yeah. All right, so this problem, the best way to do this problem is, you know, n is going to be negative today, right? Sine n over n squared. But you see there's n squared there, so you know, get sent. Oh, this should be convergent by p-series test. So question, how do you use p-series? When you apply the p-series test, all the term must be non-negative. But that's fine. You just take the absolute value. Okay? Then it's all terms positive, right? Non-negative. But this one is going to be less than this. That's my Bn. All right, so now Bn is convergent by the p-series test. Okay, p is going to be 2. This implies not n. This implies this series with non-negative terms is convergent, right? By the comparison test. You cannot just jump immediately to the original series because you cannot apply the comparison test to a series with negative terms. But that's okay. This is already good enough. Then you can say that this is, you can even put absolutely, right? Convergent. Okay. There is a theorem in the book. This is a chapter of section I forgot. It's about ratio test, road test. There's a first there. Okay. So, but anyway, absolute convergence in convergent, right? That's the reason. I think this is the best way to solve the problem. You cannot use ratio test. Okay. And look at this. Yeah. Remark. Now, when you take a notes, when you prepare for the problem, maybe you try to use a ratio test, but that doesn't work. You have to put a note why that does not work, because the limit. If we make a computation mistakes, yes, but the limit does not exist in this case. Why? Because sine n plus 1, sine n, and here's n square, n plus 1 square. This limit does not exist. At least I cannot find it. The reason is this part convergent to 1, but this part you can use the computer check when n equals 1 billion, 1 billion 1, 1 billion 2. and you find that the numbers keep changing. Okay, sometimes close to 1, sometimes close to 0. And it's hard. Maybe you can find a theorem to describe those sequence of numbers, how does it behave when n sufficient large. Okay, but it's really hard to handle. So I just say the limit does not exist. I cannot find it. So the limit doesn't exist. You cannot say it's less than 1 or equal to 1. So we cannot use the ratio, even root test. Okay, when you cannot use a ratio, then usually cannot use root test. All right. That's the last problem, not almost last. And this one, clearly, it is convergent. It's a geometry series, right? It's geometry series, n start from 1, but just be careful. It's geometry series. You don't need to prove that. Just go ahead to find it, the value. Okay, the geometry series says that when n start from 1, it's going to be a over 1 minus r if the absolute value equals 1. Okay, so you can take it out. Okay, I can, but the first term here is actually 1 over 10, right? 1 over, right? So if I take this out, I get, so I can apply the above formula, and that's going to be 1. Okay, this is actually, this actually is going to be 0.99999 all the way to 9. It's going to be 0.9 bar. Okay, that series actually represents this number. Why? Because 9 over 10 is 0.9. 9 over 10 squared is 0.09. Let's get 0.9. I just added more numbers. All right. This is a series we want to look at, power series, right? When it's convergent, when it's divergent. So I want to find the radius convergence and the intervals convergence. So this is an N. Okay, the easiest way to do is to use ratio test. Power series we can always use ratio test or root test, right? If you use a ratio test, you will get, see, be careful about this. Okay, then all right. Yeah, how do I get from here to here? Right, so you know how to do it. So this is what is the limit of this? That's a 1, right? So the answer is just a 1, x. So clearly, when it's convergent, when it's divergent, so the radius of a convergence is going to be, the radius of convergence is going to be 1. And I have to find the end point. So the radius of a convergence is going to be 1. Because by the ratio test, L is less than 1, it's convergent. L is greater than 1, it's divergent. My only problem is what happens when n equals positive 1. When n equals positive 1, this series becomes this. This is divergent, right? And why? By the P series test. Okay, P is going to be 1/2 less than 1. at point when x equals -1, you get this. But this is convergent. And it is obvious, right? By the alternating series test. Yeah, it's convergent because why this is a Bn is decreasing positive, decreasing to 0. So you don't need to spend waste of time. So then you get the interval of convergence. Okay, the interval convergence is -1 to +1. It's done. Okay, I'm going to spend 5 minutes for each bonus problem. I'm done with test within 1 hour 15 minutes. But we are given 2 hours. Okay, we're given 2 hours for the final exam. Okay. All right, this is a bonus problem. Set up integral represents area of the surface obtained by rotating the curve. Okay, yeah, set up an integral for the surface area. Okay, for the area of the surface. This is the curve is 1 plus 2x squared. Okay, and x is between 1 and 2, and this surface is it's a rotated about the y-axis. So you have to draw the graph. Right? You have to draw the graph. So y equals 1 plus 2x squared is a parabola. When x equals 1, it's like that, right? So this is a graph. It's a you know, yeah, it's like a 1 and 3, and this is going to be 2. When x equals 2, it's going to be 9 actually, right? So this is a rotate about the y-axis. That's it. So what is the formula for the surface area? Do you still remember? So this is the arc length. Okay, I'm sorry for this. I'm not. And some point here, and this is S, and that is R. So the area formula, right on the formula, is going to be 2 pi r ds. Okay, this is a formula. S represents the arc length of the curve, and that's a formula, right? We don't know how long the S. Okay, this is from 0 to L. If the length of this curve is going to be L. Okay. So, but if you want to, you can change it to the x variable or y variable. Doesn't matter. This is x and y. Okay. Right. So what you get here is I is going to be x. Then ds is going to be dx squared plus dy squared. At this point, you have to decide which variable you're going to use. I think it's obvious to use the x variable. Okay, so that is going to be 1 plus dy over dx squared dx. Okay, you can use the y variable. Okay, so use the x variable is great. Now, x is between 0 to 2, 1 to 2, 2 pi. What is r? Is x. What is ds? It's 1 plus. And the derivative of y with respect to x is 4x squared dx. Then, and you don't need to waste time to evaluate this integral. Okay, the picture is important. This formula is also important, and you have to figure out what is ds. So everything's clear when we read it, right? Don't just put the integral formula there. Without the picture, with nothing, sounds like you copy from somebody else, because we don't think you can get this integral immediately, right? When come to the lecture hall, to take the final exam. My recommendation, my suggestion is do not sit next to another student. Try to keep a distance if they're allowed. There's enough seats. Okay, number one. Number two, do not always sit to your friend, next to your friend, because I always see you in the classroom sit next to each other. I don't want to see you sit next to each other in the lecture hall, because you will be paying more attention if you do that. Okay, yeah, just randomly pick up a seat and keep a distance. It's more comfortable for you. Okay. All right, so the last problem is f of x equals e to the 3x. Find the Taylor series at a equals 1. All right, at a equals 1, not a equals 0. And the Taylor series, for this one, we design like that. You can find the derivative, but it's not easy. You know, the first method you use a definition, but I do not recommend it to you. So if you really want to use first method as a definition, you have to write down this formula first before you do. That's the first one, okay? And you don't need to prove it's convergent, divergent, but you have to find the derivative. So the first derivative, e to the 3, e to the 3x, and then you have to figure out the formula. You cannot just write down the 3 terms. 3 squared, e to the 3x, and keep it going. So the nth order, you have to find this. That's so important. You have to find this. 3 to the power n, e to the 3x. Okay, you have to find this general. Okay, then Taylor series is going to be n factorial, and evaluate, right? So 3 to the n, e to the 3, and x minus 1 to the nth power. That is the Taylor series. You have to write, don't give me 3 terms only. You have to give me all the terms, the general formula. But then when I look at the test, I find out at least 5 students just write down 3 terms. You cannot get 4 credits if you do that. Okay. Second, you use a formula. We already get this before, right? And this is n factorial x to the power n. That's true for general n. Okay, general x. So e to the 3x, so simple, right? Just n factorial 3. That's not good enough. Okay, e to the 3x. I'm not going to use that. I need a, because this is a Maclaurin series at x. I want to find it x minus, right? You have to let u to be x minus 1. Okay, so e to the 3x is e to the 3, and x is u plus 1, right? And then get e3, e to the 3u. Okay, then you use a above formula. It's n factorial and 3u to the power n. Okay, then you will get and u is x minus 1 to the power n. And this is true in general. Okay, so this is a Taylor series. I think it's the same Taylor series. Yes, it's the same. And then you have to say that this must be the Taylor series. Okay. So I think I spent 1 hour 10 minutes to complete this test in the class, including the bonus problems. Okay, and I'm not sure I'm going to complete another test next time, but I posted 5 sample tests. Okay, you should use that for practice. Okay, but also meanwhile, you go through all the review classes for test 1, test 2, at least not all my lectures, but test 1, test 2 will have a review class. You cover the problems and cover the solution, do it by yourself. Okay. If you always do it and get the right answer and even the same ideas, great, you're going to get an A. But not easy to get A plus. Okay, you always make mistakes somewhere. So, but at least you can get A. Okay, that's your guideline. you don't have much time. If you did terribly on the test, you didn't pass test 2, I can promise you pass the final exam and let you pass. Okay, so I will look at the final exam scores. That's the final result. Okay, comprehensive result. Okay, so do your best to prepare for the final exam. Okay.